Science, Week 5. For chemical reactions, word equations can be used to express them on paper. An example of this is sodium and water turning into hydrogen gas and sodium hydroxide. This word equation can be written in a chemical symbol form as well. However, under certain circumstances, you may need to balance out the equation. This is because unbalanced equations are incorrect, as they do not obey the law of conservation of mass and cannot account for all the atoms required or produced. Furthermore, if no mass is unchanged in a reaction, this implies that the types and number of atoms also stay the same. But how do the products have properties very different to those of the reactants, even though the total mass remains the same? Well, the atoms recombine in new ways following a chemical reaction to make products with different ratios or proportions of elements, and therefore have different properties. Acids and bases are two corrosive chemicals that affect people every day. They are like opposites, which means that they have the ability to cancel each other out. This process is called neutralization. Acid-base indicators are substances that can be used to tell whether a substance is an acid or a base. They react with acids and bases and produce different colors in each. When you add an acid and a base, the properties of the acid and base cancel each other out. If the same amounts of the acid and base are used, the solution becomes neutral. This reaction is commonly known as neutralization reaction. An example of this is hydrochloric acid and sodium hydroxide turning into sodium chloride and water. Acids have many different abilities and characteristics. Stomach acids help you digest your food. Acids help produce drugs, explosives, fertilizers, and plastics. Furthermore, some acids, like battery acids, are corrosive, meaning that they can react with solid substances, or in other words, eating them away. Acids have a sour taste, can turn blue litmus paper to red, and have a low pH. Some examples of acids include hydrochloric acid, nitric acid, and sulfuric acid. Bases can be found in cleaning products, as they are able to dissolve oil and grease from surfaces. Some bases are very corrosive, especially caustic soda, which is used in drain cleaners. Bases have a bitter taste, slippery feel, and the ability to turn red litmus blue. They also have a high pH. Some examples of bases include sodium hydroxide, ammonia, and sodium bicarbonate. In chemistry, acids and bases have been defined differently by three sets of theories. One is the Arrhenius definition, which revolves around the idea that acids are substances that ionize, or break off, in water to produce hydrogen ions, while bases produce hydroxide ions in solution. You can describe how acidic or basic a substance is by using the numbers on a pH scale. The pH scale ranges from 0 to 14. Low pH numbers, less than pH 7, mean that the substance are acidic. High pH numbers, more than pH 7, mean that substances are basic. If a substance has a pH of 7, it is said to be neutral, neither acidic or basic. There are two other reactions involving acids: acid and metal, and acid and carbonate. An acid and metal involves acid and metal turning into salt and hydrogen gas. An example of this is hydrochloric acid and magnesium turning into magnesium chloride and hydrogen gas. An acid and carbonate reaction involves an acid and carbonate turning into salt, water, and carbon dioxide gas. An example of this is hydrochloric acid and calcium carbonate, turning into calcium chloride, water, and carbon dioxide gas.